MicroPython implements the Python programming language that is optimized for IoT microcontrollers and embedded systems that are resource constrained. MicroPython is designed to run on devices with limited memory and processing power. It has a small storage and RAM footprint. MicroPython is compatible with Python 3 syntax. MicroPython includes a Read-Eval-Print Loop, in short REPL, which allows developers to run interactively and test code on a microcontroller line by line and evaluate results immediately. This feature is great for debugging and tracing. MicroPython provides a rich set of libraries and modules for interacting with hardware components such as GPIO, pins, sensors, motors, displays, and networking capabilities that make it suitable for building IoT devices. MicroPython is designed to be a cross-platform, including popular ones like the ESP8266, ESP32, Raspberry Pi Pico, and more. However, developers should be aware of the hardware limitations that somehow reduce code portability. MicroPython has a growing community, shared libraries, and sample projects. A packet manager called UPIP also enables the installation of additional MicroPython libraries easily. MicroPython is released under an open source license, typically MIT. MicroPython is designed to be power efficient, which is crucial for battery-powered and energy-constrained devices. While MicroPython is not a real-time operating system itself, it can be used in conjunction with other RTOSs to build real-time systems. MicroPython is a popular choice for educational purposes. The setup of the SDK is simple and quick. Installation of MicroPython usually involves flashing firmware specific to a microcontroller. This firmware contains a Python interpreter and de facto becomes a middleware between the hardware and the development Python scripts. MicroPython scripts can be executed inline via the terminal or by using a file with source code that is usually named main.py. The file should be uploaded to the driver's root folder, which is exposed via the USB connection by the MCU MicroPython firmware. A website that is a starting port for MicroPython is micropython.org. Installation of the MicroPython can be specific to the hardware, but it is quite common for the majority of the IoT MCUs. A sample MicroPython installation procedure for the Raspberry Pi RP2040 consists of downloading the firmware via the file in the binary form, switching the MCU board into the bootloader mode that exposes a flash drive, moving, dropping, or copy-pasting the file to the flash drive. The device automatically detects the firmware, then starts the flashing procedures and finally reboots. The MCU now exposes a serial port that is a Python interpreter interface, as in the case of the PC computers. Once MicroPython installs in the device, it exposes an REPL terminal via the serial port, either on the dedicated GPIO or via the serial over USB. Developing directly in the terminal is possible, but it is not convenient for complex solutions. Uploading files, even multiple, to the device can simplify managing complex and multiple file software applications. When the device restarts, a file named main.py is automatically executed. IDEs commonly use those features to simplify development and enable remote code authoring and execution.